In this video, we're going to learn how to use tree diagrams to help look at probability. So this is an example of choosing, let's say, a lunch. The first choice that you have is choosing between soda and juice. Once you choose your drink, you have three choices of bread. You can have your sandwich on a bagel, on rye bread, or on white bread. Once you choose your type of bread, you have four different sandwiches you can have: cheese, pastrami, roast beef, or turkey. When we put all those together, we have all these outcomes at the end. So I have a soda with bagel and cheese sandwich. I have a soda with pastrami on a bagel, soda with roast beef on a bagel, soda with turkey on a bagel, or soda with cheese and rye bread, soda with pastrami and rye bread, etc. If I want to figure out the probability of each event occurring, each of these total outcomes, then I can look at the probability of these happening separately. So the probability of choosing soda was 1/2. The probability of choosing juice was 1/2 because there were two choices, soda or juice. And the probability of choosing what type of sandwich bread was 1/3 because there's 1/3 would be a bagel, 1/3 would be rye bread, 1/3 would be white bread. So each of these is a third. Once you choose your type of bread, you have four more choices. So each of those is 1/4 likely to happen. Your 1/4 probability of choosing cheese, 1/4 choosing pastrami, 1/4 roast beef, 1/4 turkey. In order to get an outcome at the end, we would take 1/2 times 1/3 times 1/4, which would give me 2 times 3 times 4. 2 times 3 is 6 times 4 is 24. So every one of these choices has a probability of 1 in 24 probability of happening. And if you count each of these options, you'll see that there are 24 options. Or I can count by fours: 4, 8, 12, 16, 20, and 24. So there are 24 possible lunches. And so the probability of winding up with a lunch that is a soda and cheese and a bagel is 1 in 24. A tree diagram is also useful if the probabilities are different. Let's say you're more likely to choose soda than you are juice. Let's say you're 2/3 more likely, so your probability of choosing soda was 2/3, but your probability of choosing juice was 1/3, just because that's what you really wanted. Then you could use different numbers and multiply to get different results. Let's try to make a tree diagram that represents a family that wants to have 3 children. Okay, so we're having 3 children. Let's start with the first child. The first child can be male or female. And those are equally likely occurrences. Then from there, start to draw your branches. Your second child is either going to be male or female. So this is just representing the options the first time you have a kid, and then the options the second time you have a kid. For example, you could have a male and then have another male. Or you could have a male and then have a female. Or you could have a female and then a male, or female and then another female. Then you have a third child. So when you make a tree diagram, you're just writing out all the parts. There are 1, 2, 3, 4, 5, 6, 7, 8. There's 8 options. To summarize those options, go in a different color here. Just use the first letters. We can say the top one was MMM. The next one was MMF. So we had 3 males. We had the 2 oldest being male and the third being female. We had male, female, male. So you might be in a family where you have an older brother, a middle sister, and a younger brother. We had male, female, female. Then on these bottom options, we have female, male, male. Then we had female, male, female. We had female, female, male. And finally, female, female, female. So there are 8 total outcomes. What's the probability the family has at least 2 girls? So now that I see all the outcomes, I can highlight the ones that have at least 2 girls. So there's at least 2 girls, at least 2 girls, at least 2 girls, at least 2 girls. So there are 4 out of 8 options. And we know we write that in simplest form. So it's 1/2. What's the probability the family has at least 2 females is 1/2. We can answer other questions. What's the probability that there's at least 1 male? What's the probability that there are 3 female or 3 males or 3 females? So the tree diagram can help you with that. Another example, probability of rolling a prime number on a dice and then flipping a coin and getting heads. It's probability of rolling a prime number on a dice and then flipping a coin and getting heads. So I have how many prime numbers are there? So 2 is a prime number, 3 is a prime number, and 5 is a prime number. Those are the ones I want, but I have to account for all of them. So 1, 2, 3, 4, 5, 6. And then when I roll a dice, I have those 6 options. When I flip coins, when I flip a coin, I have a heads or tails. So let's try to create that. So these are all the total options I have. Okay, and I'm not going to write them all out, but for example, this one represents rolling a 2 and getting heads when you flip a coin, right? The one underneath that is rolling a 2 and getting tails. So the question is, what is the probability of rolling a prime number on a dice and then flipping a coin and getting heads? So prime number, 2 is a prime number. Should use my highlight tool. So there's 1, 3 is a prime number, 5 is a prime number. So there's 3 outcomes that I want over the total number of outcomes, which are 12. So 3 out of 12. So even if I don't look at the probabilities along the way, which would be 1 out of 6 for each of these, and then 1 out of 2. So 1 out of 6 times 1 out of 2 is 1 out of 12. Each of these is then a 12th. You can just count and see that there are 12 options. So that's out of 12, and then 3 that we want.